Hi, this is Hamza. I'm going to be going over my Ubisoft NEXT submission for the programming competition. So once you have the solution open, you can run it in x64 and debug or release. And you can see the game runs here. If you press A, you do a clockwise turn, and then the D is the anti-clockwise, and you can press space to shoot these fireballs at the enemy as they come. You can see the more that you kill, the score goes up in the center here, and then you have your health over here, which you start with 3, and then as these reach the end here, they start to damage the player, and then once the game ends, it sort of shows this warp effect, and then you have your highest score in the middle there, and it shows game end. So how I'm doing all of this is I've built a simple entity manager over here, which is basically it's going to hold these iObject interfaces and basically manage them so that you can add and remove them without any problems. You can also search for them by tag. And then in the init, I'm loading a scene which basically creates these new objects. The only objects being created are the level, player, and the game manager. These three will handle the actual creation of other game objects. So once that starts, it runs the start method on all of them, and then updates them, or all of the entities, every frame, and then at the end it'll render all of the entities. So let's take a look at the player here. This is the player class, and if I go into the details over here, I'm creating the sprite and all of the different things that it requires, and then in the update method I'm handling the input as well as getting the node that it's in. So if you notice, it shows blue on whichever platform it's on. That is the platform node that the player is on, which it renders down here. So it will get that node and then render it blue instead of white, which is what the level is rendering. And then it'll also render the actual sprite for it, as well as display the health. And then I also have in the interface these get message functions. These are basically used like mediator patterns. So you're sending the message to any object that you want, and it'll take that message and then react to it based on what you send it. So in this case, if it's taking damage, it's reducing the health, and then if it reaches 0, it will destroy that, or it will say that the player is dead, and then send a message to the game manager telling it that the game has ended. So if I go look in here, the end game message here, it's deleting all of the objects except for the manager, player, and level, and then it's telling the level to also end the game, which basically just tells it it's ended. If it's ended, it'll do this warp effect, so it'll change the level over time instead of just creating the level in the beginning and then rendering it. So it's also quite easy to use this interface to add new objects. So for example, if I take a look at how I'm creating these objects in this here level, or not level, the load scene here, it's very simple. I'm basically just creating them and adding them to the entity manager. If you just look here, this has nothing in the constructor except for telling it what tag this specific object is, and then the rest will be handled by what the object does instead of by the global system. So that's the level there. If I go to the proximity enemy, this is the enemy that shows up every few seconds, which the game manager spawns. And this enemy has a sprite, it has this line being rendered, and then it also gives damage to the player. So how that's happening is when the enemy reaches the end of its life cycle, it will find the player and then tell it to take damage of this much. So, and then also delete itself, otherwise it will just update its position and keep going. And then the bullet that the player shoots, it will look through all the objects and try to find the enemy, and then if the enemy is in the same node, it will check if it's close enough. So instead of using a distance function, which would be very complicated, I'm basically just taking the lifetime ratios of each of them, and then checking if they're close to each other. And then if they are close to each other, it makes sense that they're physically close to each other, in which case I'm removing the bullet and the object and then adding to the score. And that's how it works for this game. Hope you have fun.